Hi guys, this is IGCSE O-Level Chemistry, Paper 22, Extended MCQs, June 2022, Question 21. Elements in Group 4 of the periodic table are shown. Carbon, silicon, germanium, tin, and lead. What does not occur in Group 4 as it is descended? Okay, so we are going to see the happenings or the changes when the group is descended. Okay, the proton number of the elements increases. Yes, as we go down the group, the number of shells increases, so does the proton number. So this is true. Next, we have the elements become more metallic. Carbon is a non-metal and lead is a metal. So metallic character increases. This is also true. The elements have more electrons in their outer shell. Now this is incorrect because they are all elements belonging to group 4. So all of them will have 4 electrons in their outer shell. The number of electrons in the outer shell will not change. So this statement becomes incorrect. And the elements have more electron shells. Yes, as we descend the group, the number of shells in the element increases. So this statement is also correct. Therefore, the correct option for this question is option C. Question 22. Which statement about acids is correct? Acids are proton acceptors? No, acids are proton donors, not acceptors. Bases are proton acceptors. Acids transfer electrons to bases in aqueous solution. No, acids transfer H positive ions to bases, not electrons. Hydrochloric acid reacts with ammonium hydroxide to produce ammonia. No, this is incorrect because hydrochloric acid, being an acid, will not react with ammonium hydroxide. Which statement about acid is correct? Hydrochloric acid reacting with ammonium hydroxide to produce ammonia. No, no, no. It will react. It will react. This reaction would be HCl plus NH4OH, this being ammonium hydroxide, and this would produce ammonium chloride. It will not release ammonia. Oh, that is why the statement should be incorrect. This produces ammonium chloride and water. So ammonia gas will not be given off. I got confused with the fact that ammonium hydroxide is written. It could have been an ammonium salt because ammonium salts are acidic in nature. They would react with bases to release ammonia. And this is not true with the reaction of any ammonium salt with an acid as well. So here they have mentioned ammonium hydroxide, not any ammonium salt. So hydrochloric acid upon reaction with ammonium hydroxide would produce ammonium chloride and water and not liberate ammonia gas. So this is incorrect as well. And finally, ethanoic acid partially ionizes in aqueous solution because ethanoic acid is a weak acid. And weak acids are defined as being only partially dissociated in aqueous solution. Therefore, the correct option for this question is option D. Question 23. Which element have both a high melting point and variable oxidation state? This should be a transition element. So alkali metals, no. Transition elements, yes. Halogens, no. Noble gases, no. Straightforward question. Therefore, the correct option for this question is option B. Question 24. Lithium, sodium, and potassium are elements in group 1 of the periodic table. Chlorine, bromine, and iodine are elements in group 7 of the periodic table. Which row identifies the least dense of the elements in each group? So the least dense of the elements would be the one with the lowest AR. So in the case of group 1, we've got lithium, sodium, and potassium. So lithium is the first element, followed by sodium, followed by potassium. So the least dense would be lithium. So this would eliminate options C and D. And next we've got chlorine, bromine, and iodine. So chlorine is the second element in group 7, bromine is the third, and iodine is the fourth. So the least dense would be the one with the lowest AR, which should be chlorine. So option A has chlorine, option B has iodine, option C has chlorine, and option D has iodine. So options A and B were remaining. So option B having iodine gets eliminated, making option A the correct option for this question. Question 25. The reactions of metals P, Q, R, and S are shown. Okay. And what are they asking? What is the order of reactivity of the metals? Okay. So metal P does not react with water, does not react with hydrochloric acid, and reduction of metal oxide with carbon, it gets reduced. So because it is not reacting with water and HCl, so it is less reactive than hydrogen. So P is a very less reactive metal. Moving on to Q. Q has a slow reaction with water. Okay. Q reacts vigorously with hydrochloric acid. Okay. And Q is not reduced with, the oxide of Q is not reduced with carbon. So this is more reactive than iron. So P is less reactive than hydrogen and Q is more reactive than iron. Okay. R. R reacts vigorously with water, vigorously with hydrochloric acid, and no reaction with carbon. So it is more reactive than iron and it is a very reactive metal because it is reacting vigorously with water as well. And the last one, the reaction with water is very slow. The reaction with HCl is vigorous and it does get reduced with carbon. So it is less reactive than iron, but is more reactive than hydrogen. So now, in order to arrange them in the increasing order of reactivity, the least reactive is P because it is less reactive than hydrogen. Then we have Q and S because both of them react slowly with water, whereas S is much slower. So S should be less reactive than Q. This can be confirmed by checking the reduction of their oxide with carbon. Q has no reaction taking place. S gets reduced by reacting with carbon. Therefore, S should be the next element after P. As in S is even less reactive than Q and R, but is more reactive than P. Next, we have R and Q remaining. R reacts vigorously with water, Q reacts slowly with water, and both of them have no reaction with the when the metal oxide reacts with carbon. So because Q has a slower reaction, the next in the series would be Q, and the most reactive metal in the series would be R. So the order of reactivity from least to most would be PSQR, which is there in option A, making A the correct option for this question. Question 26. The number of protons and the number of neutrons in the atoms of elements X, Y, and Z are shown. So X, Y, and Z, number of protons 6 and neutrons 6. Y, number of protons is 7 and neutrons is 6. And Z, the number of protons is 8 and number of neutrons is 10. Now, since we have the periodic table with us, X is carbon, Y is nitrogen, and Z is oxygen. Okay. Which statement about the element is correct? X and Y are isotopes of the same element. Isotopes of the same element have the same number of electrons and protons but different numbers of neutrons. X and Y have different number of protons but the same number of neutrons. So they are not isotopes. Z forms an ion with a +2 charge. No, Z forms an ion with a -2 charge. X and Z react together to form an ionic compound. X and Z would react together to form carbon monoxide or carbon dioxide, both of which are covalent compounds, not ionic. X, Y, and Z are non-metals? Yes, carbon, nitrogen, and oxygen are all non-metals, making option D the correct option for this question. Question 27. Which diagram represents the arrangement of atoms in an alloy? So, an alloy is a mixture of two or more elements. So, a mixture of elements would mean that it would have different atoms of the elements randomly packed together. In A, we have got a covalent bond between two different atoms. So, this is not an alloy. In B, we have got the same atom packed closely in a solid structure. This should be the structure of a metal. In C, we've got atoms of the same element spread out. So this should be a liquid. And D, we've got two different sizes of atoms, and they're also differentiated by one being a white circle and the other being a gray circle of different sizes. So this is what an alloy looks like. Therefore, the correct option for this question is option D. Question 28. Three metal compounds J, K, and L are heated using a Bunsen burner. The results are shown. J, colorless gas produced which relights a glowing splint. Okay. Colorless gas produced which relights a glowing splint. And we are heating J in a Bunsen flame. So this is producing oxygen. So decomposition of a metal nitrate would produce oxygen. So the options are magnesium carbonate and potassium nitrate. Options A and B have been eliminated. We will continue with options C and D. Now K, upon heating in a Bunsen flame, a colorless gas is produced which turns lime water milky. So this should be a carbonate, which is there in both options C and D. But we should know that we have potassium carbonate and magnesium carbonate present. So the one that will decompose more readily would be the one with the larger size of the cation, which would be magnesium and not potassium. So this eliminates option D, and we will continue with option C. And we have no reaction taking place. Yes, potassium carbonate has a very high thermal stability, so it will not decompose on heating in a Bunsen flame, making option C the correct option for this question. Question 29. Processes involved in the extraction of zinc are listed. Heat zinc oxide with carbon. This is later. Condense zinc vapor. Okay. Vaporize the zinc. Okay. Roast zinc ore in air. Okay. So the first thing that we would do would be to roast zinc oxide or zinc ore in air. This should be our first step in the process. So step 4 being the first step eliminates options A and D. Okay. And next we would then convert zinc oxide to zinc by reacting it with carbon. So when we react it with carbon, zinc would remain and carbon monoxide and carbon dioxide would form. So step 1 becomes the second step. So between B and C, B has step 3 as the second step and C has step 1 as the second step. So C is the correct answer. Let's continue. Next, after we heat zinc oxide with carbon, we would vaporize the zinc so that it is free of impurities. So when we vaporize the zinc, step 3 remains step 3, which is there in option C. And then finally, after the zinc vapor has been separated, we will condense it in order to obtain pure zinc metal. Therefore, process 2 becomes process 4, making option C the correct option for this question. Question 30. Which process uses sacrificial protection to prevent steel from rusting? So sacrificial protection means coating a metal with a more reactive metal so that the more reactive metal reacts with oxygen and water vapor and prevents the relatively less reactive metal from corrosion or rusting. So this process is known as galvanizing. So galvanizing is there in option A. Oiling would be immersing the steel in oil. This is not sacrificial protection. Copper plating will be coating with copper, irrespective of whether it is more or less reactive than the metal being coated. So this is not sacrificial protection. And painting. Painting is done to prevent the metal from reacting, irrespective of whether it is highly reactive or it is very less reactive. So the process of galvanizing is what is known as sacrificial protection, making option A the correct option for this question.